Introduction. Welcome to our deep dive into the LEAP 1B engine, which powers the Boeing 737 MAX. Today, we'll be exploring key engine systems such as the engine start process, the role of thrust reversers, the detection of system faults, and how the built-in test equipment, BITE, plays a crucial role in maintaining engine health and performance. Engine start process. The engine start process for the LEAP 1B engine begins when the pilot engages the starter motor. This motor rotates the engine's rotor to about 20% of the operating speed, either through air bleed or electric starters. As the engine begins to spin, the ignition system is activated. Fuel is introduced into the combustion chamber where it mixes with compressed air, and the fuel is ignited by igniter plugs. This causes combustion, producing hot gases that drive the turbine. The turbine spins, powering the compressor and fan, and once the engine reaches idle speed, it becomes self-sustaining. The starter motor is disengaged, and the engine is ready for flight. Thrust reverser operation. The thrust reverser system is vital for deceleration after landing. By redirecting the exhaust gases forward, it produces reverse thrust, which helps slow down the aircraft during landing. This system is particularly useful on shorter runways or in emergency situations. When the pilot pulls back the throttle after touchdown, the thrust reversers deploy. Hydraulic actuators or electric motors push cascade vanes or bucket doors into the exhaust stream, redirecting the gases and generating reverse thrust. As the aircraft slows down, the thrust reversers are attracted and the engine returns to its normal forward thrust operation. This system reduces the reliance on wheel brakes, saving them from excessive wear, and helps the aircraft decelerate more efficiently. System faults. Despite their reliability, the LEAP 1B engine can experience system faults. Common issues may include low oil pressure or high oil temperature, which could indicate pump failure or blockages. Fuel flow issues, such as abnormal pressure or contamination in the fuel system. Electrical faults affecting sensors, or the FADEC system. The engine's built-in test equipment, BITE, continuously monitors these systems, alerting the crew if any fault is detected, and logging the fault data for maintenance teams to diagnose and address. Built-in test equipment, BITE. The BITE system in the LEAP 1B engine is designed to detect and diagnose faults in real time. This system monitors a wide range of engine parameters, including fuel flow, oil pressure, temperature, and more. When BITE detects a fault, it sends an alert to the EICAS, engine indication and crew alerting system, in the cockpit, notifying the pilot of the issue. BITE also logs the fault data for maintenance crews, providing details on the nature and location of the problem. This data is invaluable for quick troubleshooting and timely repairs, minimizing aircraft downtime and improving overall reliability. Fault indications and alerts. When a fault occurs, EICAS displays alerts with color-coded indicators. Red indicates a critical fault that requires immediate attention, such as engine failure or a severe system malfunction. Amber shows a cautionary issue that may require attention but isn't immediately dangerous. Green indicates that the system is functioning normally. For example, if there's a problem with a thrust reverser, the EICAS might display reverser fault, indicating the need for maintenance. Similarly, if the fuel system encounters abnormal pressure or flow, a fuel system fault alert will appear. These indicators help pilots make informed decisions during flight and ensure that they address any issues promptly. Conclusion. The LEAP 1B engine is equipped with advanced systems like BITE, FADEC, and thrust reversers, all working together to ensure optimal engine performance, safety, and efficiency. The engine start process is managed seamlessly, while the thrust reversers provide essential support in decelerating the aircraft during landing. BITE monitors the engine for faults, allowing for proactive maintenance and ensuring that any issues are addressed before they impact engine performance or flight safety. With these advanced systems in place, the Boeing 737 MAX, powered by the LEAP 1B engine, is not only more fuel efficient but also safer, more reliable, and easier to maintain than ever before.